Dear auditors, my name is Elisa Bossi and I welcome you to my poster presentation about cocoa plant health in dynamic agroforestry system and in traditional full sun system. This study was conducted from April to July 2019 in Western Ghana and aims to compare the health of the young cocoa plants between the two cultivation systems. Another goal was to assess the influence of good field management practices on cocoa health during the field establishment phase. But first of all, something about the two systems. Dove's plots were established transplanting seedlings of different permanent species such as acacia, cashew, timber trees, and fruit trees. On full sun plots, cocoa was the only permanent species planted. In both systems, during the field establishment phase, there are planting trees on the field, but they are not considered permanent species because they will not be replaced by farmers after 3 or 4 years. The data for this study were collected on 20 doves and on 9 full sun plots aged 1, 2, or 3 years. For the mortality rate, the dead and the alive cocos were counted. The growth rate was measured with the stem diameter and the age of the plants. The cocoa vigor and the field management were assessed through visual appreciation in a ranking of 5 categories, where 1 was very low and 5 was very high. The results showed that the mortality rate of young cocoa trees in the full sun system is statistically higher than in doves. The growth rate was found to be higher in doves plots than in full sun plots. On the other side, the cocoa vigor was found not to differ between the plots of the two cultivation systems. Statistical analysis show no significant difference in management quality between the two cultivation systems. What was found to be an important difference between the two systems is the planting scheme. In doves, cocos are planted in lines, but in full sun plots they are planted randomly. This causes some difficulty for farmers during the weeding practices. In fact, during the rainy season, the vegetation is very high and the young cocoa trees are often hidden under the high weeds. Another interesting result is the strong influence of the quality of field management on cocoa mortality rate. In fact, considering all plots, cocoa mortality was much higher in plots that were ranked with lower field management quality, what means with higher weights or with a lower rate of replanting of dead species, for example, like plantains. Because cocoa mortality and growth rate were found to be higher in doves plots, it can be concluded that plant health of young cocoa trees is higher in doves than in full sun monocultures. The cocoa vigor was found not to differ, but it should be considered that we assessed the vigor only of living cocoa plants. Independently of the cultivation system, the field management quality was found to have a strong influence on plant health and especially on mortality. The precision during weeding practices helps finding a good balance between shade provided to the young cocoa and weed concurrence for water and nutrients. The planting scheme in lines, such as the Dove scheme, simplify the management of the field for farmers. In fact, knowing the exact distance between seedlings helps farmers not to cut young cocoa trees accidentally during weeding practices. Cocoa health is then higher in dynamic agroforestry system and in well-managed fields. For this reason, it is important to encourage farmers not only to diversify the species on the field with doves to give them resilience in case of future climatic changes, but also to sensitize them to improve the field management to reduce the vulnerability of young cocoa trees during the field establishment phase. This was my presentation and I thank you for your attention and I'm here if you have questions. Thank you.
Welcome to my presentation about mapping subsistence agriculture in the southern Ville Baoulé in Côte d'Ivoire. This was my master thesis in biogeoscience last year. This work was done in collaboration with the University of Lausanne, the Centre Suisse de Recherche Scientifique en Côte d'Ivoire, and the Agroscope Regenholz. Here on the right, you see a typical yam field. Côte d'Ivoire lies in West Africa and its population is rising really quickly. 2/3 of the population work in agriculture. However, few is known about this central activity. This led to different ecosystem degradation. For example, deforestation, increasing weed pressure, and general soil degradation. This led me to following research questions. Which plants are actually grown on those parcels? What are typical yam yields? And what are the values of the soil parameters? On the right, you see a plot of 10 to 10 meters installed in a manioc field. So we measured a really high agrobiodiversity in those fields. In average, we measured 5 species in those tiny plots of 10 to 10 meters. So we speak of mixed cropping systems. Here you see an image of yam, and the yam yields were in average 100 kilograms per plot. This corresponds to 10 tons per hectare. However, variability was really high, so some farmers yielded only half of it, whilst other farmers yielded the double of it. Yam yield stagnates since years, so improved varieties are required, fertilizers should be applied, and leguminosa should be included in the crop rotation. I also measured the soil parameters, and fertility isn't that high. Actually, organic matter is seen as the most important constraint in food security in West Africa. We started a monitoring there on these very same plots, and actually now we're searching for a motivated master which is willing to continue this work. So this information is visible on the internet, and if you're interested, just write me or Felix Herzog directly. Thanks for your attention.
Master thesis on hungry palm oil mills in central Kalimantan, Indonesia. I just was at the supermarket because I needed any shampoo and chocolate to make some cookies, two products that contain palm oil. As a lot of you may know, it can cause deforestation because the demand for it is very high. Lately, a lot of companies are labeling their products as palm oil free because the effort to make sure that it's sustainable and deforestation free palm oil is just too high. The supply chain of palm oil is very complex, although here it looks kind of simple. In reality, it is more a network than a chain, which makes it difficult for companies to trace it down and make sure they sell products with sustainable palm oil. Even certifications cannot completely fix this. But especially at the mill level, it is hard to guarantee sustainable palm oil. It is said that a lot of these mills are operating below their installed capacity. Due to economic reasons, they seek to use the full capacity, and so they can act like vacuum cleaners, sucking up land to develop new palm plantation. So that's why we call them hungry mills. In my master thesis, I tried to identify these hungry mills. So first, I calculated supply catchments for each mill in my research area. This was based on travel time, because the yielded palm fruits need to be processed within 24 hours. I did an accessibility analysis with GIS, and the data I used was roads, land cover data, and topography. Then I summarized the estimated palm oil production volume within these catchments. For this, I only needed again the land cover data. The palm yield and the age of the oil palm are correlating, so all I needed was the age. The land cover data I used comes with a time series of 20 years for Indonesia. So I stacked all these layers with palm plantations and added the pixels that were labeled as palm, and so got an estimation of the age and thus the yield volume. I also added a factor whether it was a smallholder or an industrial palm plantation, since smallholders have a lower yield than the industrial ones do. Then I compared this volume with the mill capacity data I had and got my hungry mills. So this is the situation in central Kalimantan. Around 20% of the palm oil mills in central Kalimantan are expected to be hungry. Only 2/3 of the needed palm plantation area is established. Therefore, the companies are called to take action, but also the local government, because they're still given permits for new mills, and also certification organizations, since they did not show to have an impact on whether a mill is hungry or not. With these players connected to the hungry mills, the palm oil supply chain could be transformed towards sustainability.
Welcome to my poster presentation about the onion yield response to grass and leguminous cut and carry mulches in semi-arid Bolivia. My name is Laura Konen. I'm a former master's student at HAFL and I conducted a field trial in Bolivia, in Cochabamba to be precise, and I was supervised by Lindsay Norgrove and Noemi Stadler-Kaulich. We did a trial on onions because they are the second most important vegetable in Bolivia and Cochabamba with its semi-arid climate is an important production site. We wanted to see if applying mulch to onion might improve the growth yield, release nutrients in synchrony with the crop growth, suppress weed, and provide a physical soil protection and therefore prevent soil erosion. We conducted a trial in a randomized complete block design with 7 treatments, and we looked at the growth, weed, and harvest parameters. We had 3 mulching treatments, 2 shrubs. One was a leguminous shrub, the Chamaecytus proliferus, which you can see in the second picture here, and a grass, Milinis repens, which commonly grows in Cochabamba. We then also had 2 urea treatments, and all treatments brought different amounts of nitrogen to the field. In this graph, we see the onion yield on the left, so the total biomass with the box plots, and the blue line shows the harvest index. The grass mulch and the urea 80 treatment showed the highest yield, and there was no significant difference between the two. For the urea treatments, more nitrogen led to a higher yield, but this was not the case for the mulch treatments. The urea 80 treatment also showed the highest harvest index. It was significantly higher than all other treatments except urea 40. This difference between onion yield and harvest index is explained by the onion bulb weight, which was higher in the urea 80 treatment. As I've just shown, the urea 80 treatment gave the highest yield, and the grass mulch was the best performing mulch with the lowest nitrogen addition. So this mulch can be recommended if urea is not available or too expensive. It's important to know that the onion bulb is not the only product. Very often the onions are sold freshly with the green leaves, so the total biomass counts, and the harvest index might not be the best indicator. Another aspect is that mineral fertilizer, especially in the tropical context, may lead to soil acidification, soil organic matter loss, and soil degradation if applied solely without addition of organic matter to the soil. In this trial, it seemed that there were other factors important, not only nitrogen, and we suggest to take this into account when designing climate-smart resilient production systems.
Hello everyone, my name is Boke and welcome to my topic, Bamboo for Landscape Restoration. Responding to the African Forest Landscape Restoration Initiative, 30 African countries have committed to bring over 100 million hectares of degraded land across Africa into restoration by 2030. In this attempt, consideration is made to those strategies that brings an effective synergy between mitigation and adaptation solutions for the benefit of the rural poor societies. Recently, there has been an emerging discussion on the role that bamboo could play as one component of landscape restoration strategies following its fast growth, versatility, and ability to prosper in degraded soils. However, landscape restoration strategies are by far driven by climate policy debates, where bamboo is largely neglected, perhaps because bamboo is a grass, while sinks are likely limited to forest trees only. To contribute to this debate, we investigated the role that bamboo can play in carbon sequestration and storage in agroecosystems, while our assumption is that bamboo's carbon content varies along an elevation gradient between exotic and indigenous species and between intensive and extensively managed ecosystems. We conducted a destructive bamboo survey in 3 districts of Tanzania. We established 60 plots from 12 heterogeneous strata and harvested 1 culm per each plot. Results showed that bamboo biomass, carbon stock, and sequestration rates decreased with an increase in the age of bamboo culms. The ANOVA results showed a significant variation in bamboo's carbon content between the indigenous and exotic species and across an elevation gradient. The variation was also significantly influenced by the two-factor interaction between elevation and management options and elevation and species, and the three-factor interaction between the studied variables. The Horner's significant difference result showed there is no significant difference between the medium and high elevation ecosystems and also between the intensive and extensively managed ecosystems. The biggest source of variation was found to be elevation, followed by the interaction between elevation and species. The significant high amounts of carbon were found in the indigenous Oxynanthera abyssinica species than in the exotic Bambusa vulgaris species, and in the lower elevation ecosystem than in the medium and high elevation. Our results suggest that bamboo can produce tradable amounts of carbon even higher than that of the plantation forestry of Tanzania, but consideration should be made regarding the dynamics in bamboo's carbon content with species and elevation and the interaction between such variables. Regardless that bamboo is a grass, but concerns can be made regarding bamboo's environmental core benefits such as carbon sequestration and landscape restorations. Our result therefore unveils a significant step towards unlocking alternative solutions to future climate challenges in Africa. Thank you.